In this video, I'm going to show you how to do two of the problems from your homework video tonight. You'll notice that these problems are a little bit different because we're solving for exact values when a reference angle is not given to us or not implied. So in this problem, we're given that the sine of A is equal to 3 over 4 in quadrant 1 only, as you could see our restricted domain. And they want us to find the exact value of these various different trig functions. So we're going to start with the cosine of A. So my goal here is to get the cosine of A when I'm given the sine of A. So it's kind of a little bit different because we don't have a reference angle to pinpoint here. But I do know I'm in quadrant 1, so I'm going to start with my work in this box right here. So if I know I'm in quadrant 1, I'm going to start with that detail. So I have an x and y axis. I know I have some angle A that's in quadrant 1, and I can drop down from that angle A to create a right triangle. Now you have to consider what you remember about the sine. Sine of A is equal to 3 over 4. I remember that from SOHCAHTOA, sine is the same thing as opposite over hypotenuse. So I can fill in those details. If A is this angle right here, opposite that angle should be a value of 3. And the hypotenuse of this triangle, the side opposite the right angle, should be 4. If I want to figure out what the cosine is, I need the adjacent side. So to get the adjacent side, I'm going to fill into my Pythagorean theorem, a squared plus b squared equals c squared. It's going to be 3 squared plus x squared equals 4 squared, and now it just becomes a calculation, and we're going to work it down to get x squared is equal to 7, or x equals plus or minus square root 7. So now you have to make a decision. Since my triangle lives in the first quadrant, I know my x values in the first quadrant are always positive. Therefore, I know that this distance length here would be root 7 positive. So if I want the cosine of A, going back to my problem now, I know that the cosine of A is equal to adjacent over hypotenuse, which gets me root 7 over 4 for my final answer. The next three examples are all using our double angle relationships from class. I can set them up for you and show you the answers, but I want you to try to do these problems on your own because it's good practice, good reinforcement of what we did today in class. So for sine of 2a, using the double angle formula, I know that that is equal to 2 sine A cosine A. So why don't you pause the video, plug in your values from your reference triangle right here, or you can use the values that are already solved for in this problem. You should get a final answer of 3 root 7 over 8. Check the key because the work will be up there, but you want to try this one on your own to make sure you get that same answer. For the cosine of 2a, I have a bunch of different formulas that I could choose from to plug in using my double angle formula in the formula booklet. I'm going to choose 1 minus 2 sine squared theta. The only reason why I'm going to choose that one is because looking through the problem, cosine's kind of a complicated value. It has a square root in it, but sine is a nice fraction, so I just want to deal with a nice fraction if I can. So plugging in there, I would do my work through, go very slow. Remember, order of operations is big in this one. You should be getting negative 1 over 8 for your answer. So if you want to try that, pause the video and you should be there. Last one of tangent. So if you're ever going to have to find the tangent of a double angle, I would recommend finding the sine and cosine of that double angle, and that's work that we did in part B and C. So tangent of 2a is going to be the same thing as the sine of 2a over the cosine of 2a. And that work's already done for us. So we have 3 root 7 over 8 over negative 1 over 8. And you would do keep, change, flip. When you do the work through, you should be getting negative 3 square root 7 for your final answer. So you just want to check your work there. That's the first type of problem we're not covering in class. So it does require SOHCAHTOA and the Pythagorean theorem. Please feel free to come to extra help if you have any questions or rewatch any part of that video again. Later in your practice, you're going to have a reference triangle that's not in quadrant 1. It might be in quadrant 2 or 3, so you just want to make sure you're aware of that and just go nice and slow. Be aware of when x is negative versus when y is negative, and you should be okay. We're going to flip into the next problem right now. They are telling us here, let p equal the sine of 40 and q is equal to cosine of 110. Give your answers in terms of P and Q for the following expression. So they want me to rewrite the sine of 140 in terms of P. Well, if I know I'm dealing with sine and 140, well, it looks kind of similar to P is equal to sine of 40. So let's unpack this one a little bit. Sine of 40 exists in quadrant 1. Sine of 140 exists in quadrant 2. However, 140 degrees has a reference angle of 40. So the value that we get in quadrant 1 should be the same as the value we get in quadrant 2. Since sine, all students take calc, since sine is positive in quadrant 2, I don't have to change the integrity of P. It's going to just be P for my value here. Cosine of 70 is a little bit different. The cosine of 70 is in quadrant 1, but let's unpack what they gave us with cosine here. So they started off by telling us that the cosine of 110, quadrant 2 is 110, is Q. If you think about it, this has a reference angle of 70. They want us to find the value in terms of P and Q for the cosine of 70, which lives in quadrant 1. What I'm going to have to consider here is that all students take calc. So if my value is Q in quadrant 2, that's probably the negated version of it because only sine is positive here. So if I'm going back into quadrant 1 now to get the cosine of 70, I'm going to have to take Q and negate it. So I get negative Q for the cosine of 70. If they want us to find an expression for the cosine of 140, this one is a little bit trickier. I don't know what the cosine of 140 is, but I do know what the sine of 140 is. We just solved for that. It's P. So if you have to use sine to get cosine, the only identity we know that can help us do that is our Pythagorean identity. There's no triangle here for us to draw in the last problem, just the fact about sine of 140. So we have to plug into our sine squared theta plus cosine squared theta is equal to 1. Because I know this. I know what sine squared theta is. In fact, I know what theta is. I can rewrite this as sine squared of 140 plus cosine squared of 140 is equal to 1. Sine squared of 140 is just P squared because the sine of 140 we solve for is P. Well, we don't know what cosine squared of 140 is. That's what we're trying to solve for, but we do know it equals 1. Now you just want to algebraically manipulate this until we get just cosine of 140 alone by itself. So this looks a little like this. Subtract P squared to the other side, and you would have to square root both answers. So we get cosine of 140 will equal plus or minus root 1 minus P squared. However, you do want to be aware of what quadrant we're in. When we have 140 degrees, we're in quadrant 2, and only sine should be positive here. So our final answer for the expression of cosine of 140 is negative root 1 minus P squared. If you want us to do the tangent, you're just going to plug in sine over cosine. Play with that one. All the information is already solved for in parts A, B, and C, or A and B, and you should be getting for your final answer a value of P over negative square root 1 minus P squared. That's a tough one. If you need to rewatch any part, please go ahead and do that, and go to extra help if you have any questions or want some clarifying work. You can pause at any time and rewatch. Thank you for watching this video. I want you to complete the rest of the practice involving problems very similar to this that you see in the video, and more practice with equations and working with your identities. There probably will be a test question very similar to one of the ones that you see in this video, so you want to make sure that you understand it. Thank you for watching. Have a great weekend.